All right, so today's Friday. Yesterday was TCAP, and you didn't have me in general because it was only third and fourth hour. I've been gone since yesterday for the wedding in South Carolina, so today is your first day of video lecture. Wednesday, we learned about the alternating series test and the remainder theorem with it. The remainder theorem is a lot nicer, remember, than the Lagrange air-bound because it's just all about the next term. That's it. If you can get the next term, you already know the air-bound. Where the Lagrange air-bound, if you remember, was you had to look at the next derivative, and then you actually had to find the maximum of that next derivative. That was actually some thought and logic and work to do that. So alternating series test is huge on AP because it's a little bit more straightforward. So I want you guys to try this warm-up out. Notice the thing in the box, cosine of x, that's just the formula you knew, the Taylor series that creates cosine of x. This whole question wants you to find the number of terms to make the error less than 0.001 for the guy down below. Now notice when this says cosine of 1, all that cosine of 1 is using x equals 1 in this process. So I don't want you looking at that going, how in the world, why would that series equal cosine of 1? Well, it's just putting in x equals 1 to there, and 1 to the 2n is always just 1. So I want you to try out these two bullet points. You can talk to people on it and whatnot. I'm going to have you guys hit pause for this. Once you're ready to look at the warm-up and what I did, you can hit resume. So you're going to hit pause now. Good luck. All right, so let's take a look at what I did. Remember, it's an alternating series because of the -1 to the n. So the error comes from the n plus 1 term. So that n plus 1 term is the -1 to the n plus 1. And then 2 n plus 1's factorial. The part some might make a mistake on is you might just say 2n plus 1. 2n plus 1. So notice the parentheses in there. And I need that to be less than 0.001. When you look at the absolute value, the alternating series part goes away. So you're really only left with the 1 on top. Notice how I distributed the 2 to get 2n plus 2 factorial. Then you really just guess and check. And I got n equals 3 is the winner for that. So it now says show me this. So I'm going to show you. If n equals 3, that means from n equals 0 to n equals 3 will approximate cosine of 1 with an upper bound of 0.001. When I did that and I plugged in from 0 to 3 and I calculated it, boom, 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 there's actually 4 terms there. I got 0.54, da, 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 da. The real value of cosine of 1 from a calculator is this. And when you subtract, your actual error is less than 0.001. It's actually a lot less than 0.001, but remember, that was just the upper bound. Okay, so there's a warm-up. Now let's take a look at some new stuff. Okay, 9.5 continued. Absolute and conditional convergence. Okay, you have no idea what that means yet. That's why there's a lecture. So what type of series is this? Is it alternating? Which tool can we use? So I got sine of n over n squared. So the bottoms are would be a 1 squared, a 2 squared, a 3 squared. Do you agree the bottoms are always positive? Okay, it's kind of bad notation here. I'll write it this way. So the bottom would be a 1, the next guy would be a 4, then a 9, then a 16, then a 25. Okay? So then we would want to get our calculators out, and I want to check to see what sine of each of those values are. Sine of 1, 0.84, da, 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 da. Key thing, it's positive. Sine of 2 on my calculator in radian mode, 0.909, positive. Sine of 3, 0.141, positive. Sine of 4, there's a negative. Sine of 5, there's a negative. So don't worry about what the terms are exactly. I just want you to realize it went plus, 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 minus, minus. Who knows what I get next? The key thing, though, is it is not alternating. So you can't do the alternating series. But it's not all positive, and if it's not all positive, you can't do a lot of those direct comparison things. You can't do the integral test. So we're stuck because it doesn't alternate, but it's not always positive. So I don't know. Okay. Thus, as it seems every single day, I give you a new tool. So let's take a look at this. This isn't really a new tool. It's just kind of a trick of the trade. I wish it alternated, or I wish it was all positives. Well, it's too hard to make this alternate, but it is really easy to make them all positive, so I can use all those other tests that we once have used. So I'm just going to look at that thing. Make everything positive. Now, when you do that, you can say that whole thing is definitely less than 1 over n squared. And the reason you can say that is sine floats between -1 and 1. So if I use the upper part of that as a 1, that thing is always going to be the upper bound, that 1 over n squared. Now 1 over n squared converges by a p-series. So I always like to draw a picture. And the 1 over n squared guy, this thing converges. And this sine of n over n squared, the absolute value part, is always less than that. So he also converges. But that's not what the original question asked for. So I know the absolute value guy converges by, what is that called? The direct comparison test shows that n equals 1 to infinity of sine of n over n squared. That whole thing, absolute value, converges. But that's not what the original question asked. The original question asked for that thing without the absolute value. So we're kind of left at this part where I want to know what what the original guy is. Does he converge or not? But I have so far have told you that the absolute value dude does converge. So next line, absolute convergence. If a series of the absolute value converges, then the series itself also converges. Okay? So the one that we really wanted converges. Why does it converge? It converges because on that last page, we just discovered that that converged by a direct comparison test with 1 over n squared, which converged because it was a p-series. So just kind of look at that whole chain of events. I know 1 over n squared converges by p-series. So I know the absolute value guy converges by a direct comparison test. So then I know the original guy converges because of this kind of absolute convergence statement. Okay? Now, realize this check is not true backwards. And what I mean by backwards is if you replace the word convergent with divergent. You cannot say if the series, the absolute value series diverges, then the other guy also diverges. No, 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 no. This is a thing for absolute convergence. So take a look at this example. Okay? The alternating harmonic series, so it alternates, the bottom increases by 1 each time. Okay? The limits of 1 over n goes to 0. And the next guy is always smaller than the previous guy. So we know for sure that that guy converges by the alternating series. Okay, that's something that we would have done on Wednesday. Okay, now let's take a look at it with the absolute value put into it. When I put the absolute value into it, that takes away the alternating part. I'm just left with 1 over n, but we know 1 over n diverges by the p-series, where n equals 1. So in this case, The regular guy converged, but the absolute guy diverged. So anytime the absolute guy diverges, you don't know what you have. Some of the time it can diverge. Some of the time it can converge. You don't know. So I want you to, again, realize what I'm saying. If the absolute value guy converges up top, if he converges, then the normal guy converges. So if the absolute converges, the regular guy converges. But if the absolute diverges, then the original guy, you have no idea. You guys okay with that? Okay? There are two different types of convergence. There's absolute convergence, which I kind of just talked about, and then there's conditional convergence. Okay? Here are the two definitions. The series absolutely converges if the absolute series converges. Okay? Kind of, it's wordy. I know it's wordy. This one always messes me up. So don't worry. On the next slide, I have a metaphor. And the other one says the series conditionally converges if he converges, but the other guy doesn't converge. Okay? So, oh, my metaphor is on this page. I've already given you two examples today. The one with sine of n over n squared. We first looked at him absolutely, and he worked. So then we know he works normally. Okay? This one here, the blue one, we know that one works immediately by himself, but when I throw in the absolute value part, it doesn't work. Okay? So he's only conditionally convergent. Kind of think conditionally means it works some of the time, but not all of the time. It works based off a condition, where absolute says, hey, it works absolutely 100% all of the time, no matter what, which way you do it. With the absolute value or without the absolute value, it's going to work. Okay? So my metaphor is this. You are absolutely my friend even if you're in jail. So if you're you did something bad, you get thrown into jail, but you were my friend before you went into jail, and you are my friend still after you're in jail, you are absolutely my friend. So I'm in a wedding in South Carolina. Let's say my buddy got a speeding ticket, he went way too fast, and he had to go to jail. He's still my friend, regardless of if he's in jail or not. So he's absolutely my friend. Now, you are my only friend. You are only my friend if you are not in jail. That's conditionally convergent because I'm judging you based off if you are free, if you are not in jail, then I like you. But if you're in jail, I don't like you. And when I mean I don't like you, that means divergent. Now, your best friend, if he goes to jail or if he's not in jail, you love him regardless. Okay? So my metaphor stems from the word friend is talking about convergent. And jail, look at those bars. Do you see those bars? Oops, I didn't mean to do that. But look, boom, boom. I just put that squiggly in jail. Okay, if that squiggly there is in jail, but he's my friend no matter what, then that is absolute convergent. If this works, then him by himself will work. But if I only like you, if you're only my friend when you're out of jail, okay, convergent, but then when I put you in jail, you're not my friend, which means not convergent, then that's only a conditional friend. You're kind of like a, hey, you seem nice, you can be my friend. But when your friend gets in trouble and you put him in jail and he's still your friend, that's absolute convergence. This metaphor worked a lot better in my head, and if you were with me in class, it might be flowing more, but some of you might just be going, Bach, there's another metaphor that you missed on. So whatever it takes for you to realize, absolute convergent means you are convergent in jail or out of jail. So you're absolutely my friend. Conditional convergence means I'm only going to be your friend if you are out of jail. Okay, so let's look at a couple of these problems, and we're going to see if they are absolute convergent or conditional convergent, or if they just diverge. Okay, so the first one here, I'm going to write out a couple more of the terms so you can kind of see the idea. This is going to be, it alternates, plus minus plus minus plus 4 factorial over 2 to the 4th, minus 5 factorial over 2 to the 5th, plus 6 factorial over 2 to the 6th. Just think through that. Let's stop on the 6 guy. Just look at the 6 guy. This here would be 6, 5, 4, 3, 2, 1. All over the 2 to the 6 guy would have a 2, a 2, a 2, a 2, a 2, and a 2. You're always going to have one set matching up. Those can cancel out. But realize this. That 6 factorial is going to have a 6 and a 5 and a 4 and a 3 on top versus just a couple more 2s on bottom. Which guy is always going to be more powerful? The factorial part or the 2s on the bottom part? The top part. This guy's bigger. So if this guy's bigger, then regardless, I am not going to 0. So by divergence test, this is divergent. Okay? So I don't even have to do anything else on that. It just is divergent. So if it's divergent by himself, out of jail, if you're not my friend out of jail, then there's no way you're my friend in jail. Whole story here, this guy diverges, you're down on A. Okay? Let's look at B. Okay? So on B, I see this, so it's alternating series. Okay? The terms go to 0. And 1 over this is always smaller than 1 over this. So this by himself converges. Okay? Since it converges, let's look at it with the absolute value with it. I already know he's my friend outside of jail, but I'm curious if he's still going to be my friend, boom, boom, in jail. So this is looking at that, which is stating P equals 1/2 for the P series. So this diverges. So again, you're my friend currently out of jail, but when I put him in jail, he diverged, which means he's not my friend. So this whole thing is whoops, sorry about that. This whole thing is conditionally converging. Because outside of jail, it worked by the alternating series. But inside jail, it didn't work because my exponent was 1/2, and that's P series diverges. Okay? Give you a moment if you want to write these down. And maybe try these out. Okay? I'm going to stop the video. You're going to open up the next video here in a second. But try these 2 out. See what you can figure out on these. It's the exact same type of style as example 5 that we just did. And we'll try this out on the next video.